We have seen that the definite integral of a non-negative function has the meaning of the area of the region bounded by the graph of the function. Let us illustrate this result by a few very simple cases. If the function is a constant, then the graph looks like that, and the region is just a rectangle, and it is easy to find the area of the rectangle. What about the result using the integral? Does it give the same result? Okay, let's try. First, using the integral. Integral from a to b, these are the values, of the constant dx. We can either factor out the constant and integrate 1, or we can integrate the constant, and anyway we get kx. Okay, so let's forget. Let's factor out the constant first, and we have 1 dx, and integral of 1 is x from a to b, which is k times b minus a. And yes, this is in perfect agreement with the geometrical way, namely this is b minus a, this is k, and when we multiply these two sides we get the area of the rectangle. Well, that's good. What about a more complicated function? Say k times x. And yes, from a to b. Then, using the integral, we have integral from a to b, kx dx. We can again factor out k, and we have integral from a to b x dx. And now the antiderivative for x is x squared half. From a to b. And then we substitute b and a for x and subtract. So we have k, and we can factor out 1 half. And we have b squared minus a squared. Well, is it in agreement with some simple geometrical arguments? This area can be considered as this large triangle minus the area of the small triangle. And the large triangle, if we denote this O, and if we denote this Q and Q, then the area A is the area of the triangle OPQ minus the area of the triangle, and let's call it R and S, these 2 points, and this small triangle is ORS. ORS. But the area of the triangle is 1 half of the product, base times height. So the large triangle is 1 half, and the base is b, and the height is the function value at b, which is kb. Minus, and the area of the small triangle is again 1 half of base times height. Base is a, and height is the function value at a, which is ka. We can factor out k half, and we have b squared minus a squared in perfect agreement with the result obtained by integration. That's good. It would be sad to get a different result, right? Perhaps a special case when k is 0. The 0 height rectangle has a 0 area, and if k is 0, this is indeed 0. Now, let's consider some perhaps more complicated function. Say if f is x squared. This time we are just left with the integral approach. I don't know of any formula to find the area below the parabola. Why is x squared looks like that? And let's consider, say, the area of this region. Then that will be integral from 0 to 1, the minimal x and maximal x values of integral of the function itself. Integral of x squared is x cubed third from 0 to 1. So we have 1 cube, which is 1, divided by 3 is 1/3, minus 0 cube, which is 0. We don't have to write it. 1/3. It's always a good idea to check the result roughly, approximately, whether it agrees in some round estimate. This area is definitely less than the area of the rectangle of the square, and the area of the square is 1. Yeah, this is less than 1. That's okay. If it were greater than 1, well, I don't know. And this is even less than 1/2, because 1/2 would be the area of this triangle. But this is convex function, so it's rounded this way, and by this amount, this is less than 1/2. Perhaps another interesting example, let's consider the function sine from 0 to pi/2. And this area will be integral from 0 to pi/2 of sine of x dx. But integral of sine is minus cosine from 0 to pi/2. So we have minus cosine pi/2 minus cosine 0. But cosine of pi/2 is 0. Cosine of 0 is 1. And minus gives plus. So the result is 1. Well, this is good to remember. We can conclude that the function sine likes the number 1. And I can give you 3 arguments. The function y is sine of x has maximum equal to 1. It has the slope of the tangent at the origin equal to 1. And the area of this half of the first half is equal to 1. This is good to remember. Well, and if you go on to pi, this is the same, so area 1 here, area 1 here, so the total area would be 2, that's natural.